So as we study different functions, we will always go through and make sure we can find each of the characteristics of the graph so that we can describe the graph in a variety of ways. So we've already been finding the vertex and the domain and range for functions. It's very similar for absolute value and quadratic because the shape is almost identical. It's just V shape versus U shape. So again, to find the vertex, we take the opposite of the inside number and we use the outside number. The domain is all of the x values that you can see represented in the graph. And so when we look at this drawing, we can see that there's a left arrow and there's a right arrow, and all the x values in between are getting used. So just like with an absolute value equation, the domain for a quadratic equation is going to be the same. It's all real numbers. It's from negative infinity to positive infinity. The range is a little bit more interesting. We look at how far down the graph goes. That's going to be the y-coordinate of the vertex, or it could be arrows. In this case, it's the y-coordinate of the vertex, so it's -6. I put a bracket with it because that value is included on the graph. And it goes from -6, and then there's up arrow, so that's from -6 to infinity. For example 2, the vertex, there's nothing written in the parentheses. In fact, if I wanted to rewrite this equation, I could say -2/5, and then I could write x plus 0 squared plus 1. I could rewrite it like that. And so the vertex here is 0, 1. The domain, again, is negative infinity to infinity, just like every other quadratic. And then the range, this graph goes down forever, so we have some arrows. And it goes up to the vertex, and we're going to use the y-coordinate, which is a 1. So negative infinity to 1. Increasing and decreasing intervals. So again, we're looking at what x values make the equation have increasing y values, so going up. What x values make the function have decreasing y values, so it's going down. So I'm going to do just like I did before with the stick figure. I'm going to start with my stick figure right here. And he starts at a left arrow, which is negative infinity. And you can see that he's going downhill to start with. And then he hits the vertex, which has a value of 5, an x value of 5. And then after he hits the vertex, he goes up, so he's increasing. And he's increasing to a right arrow, which is a positive infinity. So the increasing interval is from 5 to infinity. And the decreasing interval is from negative infinity to 5. All right, we'll do the same thing for the next example. So I'm going to go ahead and take my little stick figure and draw him here. We have a left arrow that's negative infinity. So first he's going uphill, he's increasing, and he increases to the vertex right here, which has an x-coordinate of 3. And then after he gets to the top, then he starts decreasing, and he decreases all the way to a right arrow, which is infinity. So the increasing interval is from negative infinity to 3. And the decreasing interval is from 3 to infinity. For maximums and minimums, we're looking for high points or low points of the graph. So this graph does not have a high point because there are arrows. So for maximum, we say none. We only want to write an answer for this if we can write it as a point, an x and a y coordinate. So for that, we're going to say none. For minimum, we're going to say the vertex, and the vertex is -1, -7. For example 6, this graph has a maximum. It does not have a minimum because there are just arrows. So the maximum is -5, 10. All right, next we want to make sure we can find the X-intercept and the Y-intercept. I think so far I've focused a lot on doing this using Desmos, but some of you guys do have graphing calculators, so I want to show you that as well. So if you're using Desmos, you should try typing this in to make sure you can get it. To type the pi in on Desmos, you just type the letters pi and it will plug in the pi for you if you're using a keyboard. I think if you're using your cell phone, I believe there's a pi button, but I could be wrong. So either way, if you type pi, it will put it in for you. So for those of you with graphing calculators, we're going to type the negative. The pi is right here. It's the second version of the up arrow, so we're going to hit second up arrow to get the pi in there. And then we have parenthesis x plus 2 parenthesis squared plus 7. So I'm just typing it in exactly the way it looks. What I'm going to do next is I'm going to graph the line y equals 0. So the line y equals 0 is this line right here. It's also known as the x-axis. The reason I'm going to graph that on my calculator is because then I'm going to be able to find where these two cross. And I'm going to be able to find where these two cross, and those are the x-intercepts. So I'm going to go ahead and graph that. There's my graph. It is graphing the x-axis even though I can't see it. So now the way that I do this on a graphing calculator is I hit second trace. Number 5 is intersect, and you can find where those two lines intersect each other. So when I have the cursor, it doesn't matter where the cursor is for the first point. If you just press enter, enter, enter. So right down here, enter, enter, enter. Then it gives you the first x-intercept. So negative 0.5070. So I didn't move anything. I just pressed enter, enter, enter. That was it. That's all I did. To find the second x-intercept, I hit second trace, again, number 5. And this time I just have to move the cursor so that it's closer to the other point. That's all I have to do. And then same thing, enter, 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 negative 3.493. Okay, so that's how you find the x-intercepts. To find the y-intercept, you're going to hit second trace again. You're going to do option number 1, which allows you to plug in any value that you want, and you want to plug 0 in for x. So negative 5.566. All right, so let's go ahead and do that one more time with a new graph. So square root 2. Remember, if you're doing this on Desmos, you can type SQRT, or you can just get that other keyboard up and hit the square root button, either one of those. You know, I was talking and I had too many squares there. Square root 2, x minus 1 squared, minus 8. There we go. So there's my equation. I already had that second line graphed, y equals 0. That was the x-axis. It was already graphed. So now I hit second trace, number 5. It doesn't matter where I am. I just press enter, 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 and it will find one of them. So negative 1.378. And then for the other one, second trace, number 5. I'm just going to move the cursor so it's closer to the other one. I don't even have to get right on where I think it is. I just have to be closer to it. And then I press enter, 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 3.378. For the y-intercept, I'm hitting second trace. I'm using option number 1, and I'm plugging in 0. 0, negative 6.586. And if you are not someone who has a graphing calculator, you should be pausing the video to make sure that you can type those things in on Desmos, because things like this are fair game for me to put into an equation and for you to work with. So I don't want to hear anyone say, Ms. Rice, I don't know how to do that on the test day, because you should have figured it out before then. All right, so continuity, you can trace your finger with it without picking up your finger. And that's the same thing of this. It's a U-shaped graph, so I can trace it. It's still pretty standard. We haven't hit any functions yet that are not continuous, so we're not too worried about that. Next, the end behavior. Remember, end behavior just describes the arrows. This is exactly the same as absolute value graphs. So for this parabola, the left arrow goes up and the right arrow goes up. So I'm going to say as x goes to negative infinity, y goes to infinity. So that means the left arrow goes up. And then as x goes to infinity, y goes to infinity. That means the right arrow goes up. So left arrow up, right arrow up. For this one, as x goes to negative infinity, y goes to negative infinity. So the left arrow goes down. As x goes to positive infinity, y goes to negative infinity. So the right arrow goes down as well.